GCE Advanced Level Chemistry Practical Series, experiment number 6. Experimentational determination of the molar mass of magnesium with the use of the molar volume of hydrogen gas. The aim of this experiment is to develop skills needed to determine a molar mass of a metal. In this experiment, we are going to be using magnesium, and we are going to use HCl to react with magnesium and produce hydrogen gas. We will collect the hydrogen gas, and using the molar volume of hydrogen gas, we will calculate the number of hydrogen gas moles that is produced. Using this number of hydrogen gas moles and the balanced chemical equation between magnesium and hydrochloric acid, we are going to be determining the molar mass of magnesium. Now, without further ado, let's go on to identifying the reagents and the equipments used for this experiment. Let's identify the reagents and the equipment we will be using for this practical. We'll be using 2 moles per decimeters cube concentrated HCl. We'll be using a measuring cylinder to measure the HCl that we are going to be using. We'll be using a funnel, a wash bottle, a digital balance, magnesium strips. We'll be using a thermometer, a cork to hold the magnesium strip in place, a copper wire to tie the magnesium strip and connect to our cork. We'll be using a burette, a retort stand, and we'll be using a 1 liter beaker filled with distilled water. Students, in the lab, we normally have magnesium in the form of magnesium strips. Magnesium strips do not appear to be shiny like other metals. The reason behind this is magnesium strips are coated with a magnesium oxide layer that makes it appear a dull gray color. Before we use magnesium for any reaction, we need to make sure that you sand down this gray color magnesium oxide layer so that you obtain this shiny silver color magnesium pieces. Magnesium strips here after sanding down the magnesium oxide layer that was coated on top of it. So before we use magnesium for this experiment, we have to make sure to sand down the magnesium oxide layer. Now, we have prepared these magnesium strips so that the mass of each of these magnesium strips are 0.05 grams. And in our next step, we are going to measure these magnesium strips again to see if we have the correct mass. Before starting this practical, we have prepared magnesium strips that are 0.05 grams in mass. Let's double check if the mass of these magnesium strips is in fact 0.05 grams. We have our digital balance here. We can see it reads 0 and the unit of this balance is grams. After ensuring all of these things are in order, we can go ahead and measure the mass of this magnesium strip. As you can see, the mass of this magnesium strip is 0.05 grams. Now, let's take this magnesium strip and tie it with our copper wire. After tying it to our copper wire, making sure that it is tightly held to the copper wire, we can move on to our next step. Now, let's add 5 cubic centimeters or 5 milliliters of 2 moles per decimeters cube HCl into our burette. We have our burette that is washed with distilled water here, and we are going to make sure the burette is properly closed because we are dealing with concentrated HCl acid. So when you're handling concentrated HCl acid, make sure to not spill any HCl because it could be harmful. After ensuring that the burette is properly closed, we are going to be now adding 5 milliliters of HCl into our burette. 5 milliliters of HCl with the use of our measuring cylinder. We have our HCl solution here. We are going to pour it into our measuring cylinder. Now let's pour 5 milliliters of 2 moles per decimeters cube HCl. When you are measuring a solution or any liquid with a measuring cylinder, make sure that you bring the measuring cylinder to eye level so that you can see if the meniscus of the liquid or the solution aligns perfectly with the measurement you are trying to take. So after bringing it to my eye level, I will add the right amount of HCl until the meniscus aligns perfectly with the 5 milliliter line. Now the meniscus aligns perfectly with the 5 milliliter line. I'm going to use this and transfer this 5 milliliters into our burette. Now let's transfer this 5 milliliters of HCl into our burette. We made sure the burette is properly closed. So afterwards, we can take a funnel and place it on top of our burette and transfer this 5 milliliters of HCl into our burette. After transferring our 5 milliliters of HCl, we have to add distilled water into this burette all the way to the top. When we are doing that, we have to make sure that we do it in such a way that the HCl layer does not get disturbed that much, because we do not want the HCl to get mixed with the water at this point. The reason for this is we need to have some time to fix the magnesium strip into our burette and then turn the entire burette upside down. If HCl is completely mixed with the water, as soon as we introduce the magnesium strip into this mixture, the reaction will start to happen. If this reaction starts as soon as we insert the magnesium strip into the burette, then some amount of the hydrogen that is produced will go out of the burette before we secure this setup in this retort stand. So to avoid HCl coming into contact with the magnesium strip as soon as we introduce the magnesium strip into the burette, we have to make sure that we add water to this burette in such a way that it does not allow the HCl here to get mixed evenly and produce a homogeneous HCl solution. So I'm going to be using a wash bottle, and I will be adding water along the wall of the burette so that the HCl here does not get disturbed enough to mix well with water. Now, as you can see, we have added water all the way to the top. And now, we will be using this magnesium strip secured in a copper wire. We will be inserting this magnesium strip into this burette, and then we will be securing this copper wire and the magnesium strip with the help of our cork. Now, if you observe clearly, the cork that we are going to be using has a hole in the middle so that it allows the water to get removed from the burette when we are collecting hydrogen through downward displacement of water. Now, let's insert this magnesium strip into our burette. As you can see, there is still no reaction happening. We do not see any air bubbles being formed here. So that means we have successfully added the water without mixing it much with HCl. We can now turn this burette, and while keeping a finger underneath the cork, we are going to place the burette inside water like this, and we will secure the burette with the help of our retort stand. We'll place it properly like this, and now we'll have to make sure that we bring the water level to 50 milliliter mark that we have over here before the reaction starts. Right, we have brought the water level to the 50 milliliter mark, and after we have turned it upside down for a while, you can see the HCl that was present here at the bottom of the burette now starts reaching down because we have turned the burette upside down. So HCl was present here. It is now starting to reach our magnesium strip. And as it reaches the magnesium strip, we can see a reaction taking place and production of hydrogen gas. So if you allow it to stand for a while, you will see hydrogen gas being produced due to magnesium reacting with HCl. Let's wait for a while and allow the hydrogen gas to collect in the burette and take the volume reading of the hydrogen gas that is produced. It's been about 15 minutes now. As you can see, as the reaction continue to proceed, this area of our burette is getting filled with hydrogen gas. And as it gets filled, water is displaced downward. So we say this is a downward displacement of water method of collecting hydrogen gas. If you pay attention to over here, the magnesium strip that was present over here has little by little gotten smaller and smaller as it reacts with the HCl, and a part of it has broken down and gone to the bottom as well. You can see that is also still reacting with HCl and producing hydrogen gas. But after the magnesium strip has completely reacted, you would see that the water level will not move downward anymore, as all of the magnesium has completely reacted with HCl. There will be no more production of hydrogen. At that point, we will allow the system to come to an equilibrium, in the sense we will allow the system to settle so that all the gas is collected, even the tiny bubbles you see here mixed in this area of the burette, they should all get collected in the upper part of our burette. After everything has settled down, we will be taking a look at the temperature of the system as well as the burette reading that we have when the reaction has gone to completion. Students, we have now completed this practical. We can see the reaction is no longer happening because you don't see any gas bubbles being formed here. You do not see the presence of the magnesium strip that we added in the beginning of the reaction, meaning all of the magnesium has completely reacted. Now, if you take a look at the reading over here, it is at 0.2 milliliters. We started the reaction by filling water all the way up to 50 milliliters. Now, the water level inside the burette is at 0.2 milliliters, meaning we have collected 49.8 milliliters of hydrogen gas. However, this hydrogen gas is not at the atmospheric pressure. For it to be at atmospheric pressure, the water level inside the burette and the water level outside the burette should be equal to one another. So, the reading that we take here is not entirely correct. We have to first make sure the water level inside the burette is equal to the water level outside the burette. Let's go ahead and do that. Right. Now we have the two water levels aligning with one another. At this point, it is safe to say the pressure of the gas that is inside the burette is equal to the pressure outside burette, meaning the hydrogen gas collected inside the burette is now at atmospheric pressure, which is 1 atm. Afterwards, we can take a look at the reading and take the actual volume of the hydrogen gas we have collected. The current reading is at 49.9. Earlier, when it was submerged, it was at 49.8. Now it is going to be 49.9, meaning we have collected exactly 49.9 milliliters or cubic centimeters of hydrogen gas at 1 atm pressure. Now, we have one more measurement to take, that is the temperature of this water. Because when you take the temperature of the water, we can have an understanding of the temperature of the gas here, because they come to an equilibrium where the temperature of the water and the temperature of the gas will be equal to one another. So, let's take the temperature of the water here. Temperature of the water is 23 Celsius. 23 degrees Celsius is the temperature of the water. After taking the temperature, we have now collected all of the information we need to calculate the molar mass of magnesium. However, we only conducted one test. Let's move on to another test so that we can be very certain of the measurements we have taken. So, we will repeat this test 2 more times. Using these 3 sets of data, we can calculate the molar mass of magnesium a bit more accurately. Let's move on to our second trial. In the second trial of this experiment, we will be going through the same steps that we followed in our first trial. However, we will have to measure the mass of the magnesium strip again to see if it is around 0.05. We will take our magnesium strip, we will turn on our digital balance, and we will place our magnesium strip to see if the mass of the magnesium strip is close to 0.05. Over here, we can see the mass is in fact 0.04. That is okay. We can go ahead with this mass and continue on with our experiment. We have to make sure that we note down this mass of the magnesium strip that we used for the second trial, so that when it comes to the calculations, it will be easier. Now, let's move on to tying this magnesium strip onto a piece of copper wire and then adding it into the burette. We have tied it into our copper wire. After tying it with our copper wire, we can place it aside. Now, let's measure 5 milliliters of HCl. We have our measuring cylinder here. We'll take our HCl. We will measure 5 milliliters of HCl. And we are going to add this 5 milliliters of HCl into our burette. Before adding the HCl, we have to make sure that the burette tap is properly closed. After making sure that it is completely closed, we can move on to adding our HCl. After adding our HCl, we are going to add some water into this burette. We have to fill this burette all the way up to the top with distilled water. Like we did in the first trial, we will be adding water along the wall of the burette so that it doesn't mix that well with the HCl layer that we have at the bottom of the burette. Now we have added water all the way to the top. All that is left for us to do is adding this magnesium strip like so and securing it with our cork. After securing it with our cork, we will place our finger on top of the cork to ensure that no air or water will go out, and we will invert this burette and place it inside this 1 liter beaker. After placing it in students, before the reaction starts, we have to make sure that the water level is at 50 milliliter line. So we have to bring this water level by opening the tap to our 50 milliliter line. Right. Now you can see the reaction has not yet started. We saw when the reaction starts, there will be formation of gas bubbles. You can see the reaction has not yet started because we saw in the very first trial how it looks when the reaction has begun. So we will give it some time for the HCl that was present on this upper part of the burette to go down to our magnesium strip and start a reaction. After the reaction starts, we will allow it to go to completion, and then we will take the measurement. Now, everyone, you can see that the reaction has started. Now, it's a very clear difference. You can see entire burette is filled with air bubbles. So these bubbles that you can see here is hydrogen gas bubbles that are formed due to the reaction between the acid HCl and a metal which is magnesium. So when HCl and magnesium reacts, it produces hydrogen gas. You can see this hydrogen gas rising up this burette and collecting at the bottom of the burette. This reaction will take place for a while, so we'll allow the reaction to take place for a duration of about 10 to 15 minutes, and we will observe whether the magnesium strip has completely reacted, and at the point at which we do not observe the presence of magnesium strip, we will take the burette reading, and that will serve as our hydrogen gas volume for calculations. Let's allow the reaction to go to completion. Now, all of the magnesium that was in the burette has now completely reacted. After all of the magnesium has completely reacted, what we see here in the burette is the hydrogen gas that was produced due to the reaction between the magnesium and the hydrochloric acid. Like in the first trial that we did, we can take the reading when the burette is submerged underwater like this. We can see the burette reading is at 0.3 cubic centimeters, meaning the amount of gas that is collected is 49.7. However, just like in the previous trial, we have to keep in mind that when the water level of the burette is below the water level of the beaker, that means the pressure of the gas inside the burette is not at atmospheric pressure. So we have to lift this burette up until the water level of the burette aligns perfectly with the water level of the beaker. Now, the water level inside the burette and outside the burette is aligned perfectly. Let's take a look at the reading at this point. The reading at this point is 0.2 cubic centimeters, meaning the amount of hydrogen gas collected in this burette is 49.8 cubic centimeters. With that information, we need to take one more measurement, that is the temperature reading. We have our thermometer here. We'll place it inside this beaker and let's observe the temperature reading of this water. Just like in the previous trial that we did, the temperature of this water is at 23 degrees Celsius. Now, after noting down these measurements, the mass of the magnesium strip was 0.05 grams, and then we collected hydrogen gas that is produced when we reacted the magnesium strip with HCl. So the volume of the hydrogen gas was 49.8 cubic centimeters or 49.8 milliliters. The pressure of the gas was considered to be the atmospheric pressure, which is 1 atm, and now we have the temperature, which is 23 degrees Celsius. With this information, let's move on to our final trial. We have come to our third and final trial. So when we are starting this trial, we are going to first measure the mass of the magnesium strip we are using. We have our digital balance here. Let's place it on the digital balance to see if it is 0.05. As you can see, the mass of the magnesium strip is 0.05 grams. Just like in our previous steps, let's take our copper wire and tie it around this magnesium strip like this, and we'll set it aside. Afterwards, we are going to take our measuring cylinder. We'll keep the balance aside. We'll take our measuring cylinder and measure 5 milliliters of 2 moles per decimeters cube HCl. After measuring 5 milliliters of HCl, let's take our burette once again and make sure the burette is tightly closed. After ensuring it is tightly closed, let's add the HCl that we measured into our burette. After adding our HCl, we are going to add water, just like in the previous two attempts, without disturbing the HCl layer. We are going to add water along the wall of our burette, like so. You can use a wash bottle for this purpose. After adding HCl all the way to the top, we can now include our magnesium strip. Then we'll place our cork and secure the magnesium strip in place, like this. Afterwards, we'll close the opening of this cork and turn the burette upside down, and we will place the burette inside water like this. I've used the retort stand to hold the burette in place. You can see the reaction has not yet started because HCl is slowly going down towards magnesium. We do not see the formation of any gas bubbles. So during this time, we can align the water level of the burette with the 50 milliliter line that we have here. We have our 50 milliliter line, so we are going to align the water level with the 50 ml line. After setting this setup, we are going to wait until the reaction starts. Reaction has not yet started because we can see there are no gas bubbles being formed around magnesium, indicating that HCl has not yet come down to react with the magnesium strip. After a while, you can see that the reaction has initiated when you can observe the formation of gas bubbles. Now you can see little by little small gas bubbles are formed around magnesium, and they are going up the burette and collecting at the top part of the burette, which means our reaction has started. After a while, when the reaction has completed, we will come back to take the gas volume measurement. We have come to the end of our third trial as well. You can see the magnesium piece has completely reacted with HCl, and we do not observe formation of any gas bubbles, meaning the reaction has gone to completion. Over here, the reading we are observing over here is 0.2, which means the water level inside the burette is aligning with the 0.2 line, telling us that we have collected 49.8 cubic centimeters of hydrogen gas. Like I mentioned in the previous two trials, this volume is not the correct volume because the pressure inside the burette is not the same as the pressure that is outside of the burette. To make the two pressures equal to one another, we have to make sure the two levels inside and outside the burette aligns with each other. We have to bring it down a little bit further. We have to bring it a little bit further down. Now we can see that the two water levels inside and outside the burette are aligning with one another, and the reading at that point was 0.1 cubic centimeters, indicating we have collected 49.9 cubic centimeters or 49.9 milliliters of hydrogen gas. Let's take a look at the temperature. We have our thermometer here. We will place it in the water beaker, and the temperature is at 23 degrees Celsius as in the previous two trials. So the temperature is at 23 23 degrees Celsius. In the first two trials as well, we had a temperature of 23 degrees Celsius. Now, let's go over the readings we have obtained so far. In this third trial, we started with measuring the mass of the magnesium strip. Magnesium strip had a mass of 0.05 grams, and the volume of the hydrogen gas we collected was 49.9 cubic centimeters. The temperature of this water was 23 degrees Celsius, and the gas that was collected was at 1 atm pressure. With this information at hand, we will move on to the calculations revolving around this experiment and other theory parts that are important to this practical in our next session.